As we are wrapping up this unit number 11, quiz number 10, it doesn't seem possible. So we're going to notice here at the start, we're going into review mode first. So if you've got your Unit 10 notes handy, great. If not, we can update a couple of things. If you find something that is useful from the quiz preview and you cannot find your prior notes, maybe, just maybe, you find a spot somewhere on your current notes, maybe, to be able to add in something that you think might be helpful. But a lot of times, just focusing in and doing this with me might get you enough of what you need to get there. Okay, so axis of symmetry. All right. Given the function, and they give us an equation here, find the equation of the axis of symmetry in the vertex. Use x equals the opposite of b over 2a. So reminders. Your b value is the number in front of x. Every time. Not x squared, the number in front of x. The a value is the number in front of x squared. So your a and b always come from the x squared to the x. They're not going to come from the end here. So all I have to do, if I know that, is copy and plug them in. So it's the opposite of 8, so negative 8. Got to remember the negative. Over 2 times my a value. As we said when we did these initially, multiply these numbers in the bottom together first before you do anything else. And then if we need the calculator, we can use it. Let's try that again. There we go. I've got my axis of symmetry. I've got my x. Once I have that, there's one more step. Okay, your vertex we're going to substitute the x value we just found into the y equals equation. That's going to be x. So, I'm going to start with my y equals. Every time I get to an x, I'm going to put it in parentheses, because that's going to help us deal with any negatives that are going on here. So every time there's an x, we're just replacing it. And if I go to my calculator for help, I do not have to put it into the y equals part. I just got to type this second part in with the parentheses. I keep saying that over and over and over. Oofda. And once we have that, your vertex is your x value and your y. So if there's part of that that you're like, if Hardy's going to give me that, and I am, okay, I can do this part. This part I'm not so sure about. Maybe you even use your Unit 11 notes and put like 10.4. Substitute x into y equals, or maybe just jot this down at the top or somewhere on a side page. But make it where you know that that's what you're being asked to do. So as we move down a little bit, okay, the application. Describe 2 ways that the graph of these two are different. In other words, I'm asking you, are there any shifts or stretches? So again, that's one where if I have it, I'll have them right there. Otherwise, there's a few ways I can get myself some reminders. So if I remember things like what's going on inside the parentheses is always left and right, the opposite of what I would think, and whatever's on the end is up and down, that would come in handy too. Because if I know that, I'm just going to look at this and I'm going to say, ooh, plus is left, so left 3. I'm going to show you another way as well. Plus 5, plus is going to be up. And I'd write that down. Here's my other way if I wanted to do it visually, if I wanted the calculator to help me. I can type this into the calculator. Make sure I get everything typed in. So if I want to be visual, if I start from the origin and I want to get to the vertex, where did I go? I went left and I went up. I can literally see where those are at. Or, you're like, good gosh, Hardy, how many options do you have? Well, I got lots. Remember when we were always talking about seeing symmetry above and below? I found my middle, my vertex. To get to my vertex, I went left 3, negative 3. I went up 5 to positive 5. There are so many different ways that you can do this, but you've got to lock in on one of them. Because again, Hardy running his mouth is not going to be one of the options tomorrow. So if I'm thinking just from what we did again here on the second one, this plus 7 is not in parentheses. So that would be up 7. And the negative, when it's in front of x, means it's going to reflect. Even if you just put the word reflect, you're like, okay, now how in the heck am I supposed to remember that if I don't remember off the top of my head? Again, if you put it in the calculator and just look at it, looking at your vertex, what do I notice? I went up to get there, and my parabola is opening down. It's a reflection of what I normally see, which is it opening up. Hardy, can I just say it opens down? I'd give you like half credit for that. I mean, that is a difference. It opens down. But this is the correct way to say it, that it reflects, because now it's opening the opposite way. So again, your notes help. Knowing your form helps. The calculator can help. You got to find one of them that's going to work for you. Or maybe, just maybe, if you've still got your Unit 10 notes and maybe you didn't complete them somewhere, I still got them on the stream. And you could update them and use that. So I'm just saying. Okay. Formula for the height is used by this equation. We give you stuff. Find the time t for the rocket to meet your maximum height. Okay, first things first. We're going to use this formula. Well, what are the numbers? The number in front of t squared is a. The number in front of t is b. Same order just like it was in front. First one's a, second one's b. So we got t is the opposite of b, so negative 144 over 2 times negative 16. Same advice I gave on the other one, because I know some of you who might not be locked in now are going to notice this later. If I type this in, don't write this answer down that you're about to see. Man, that took a long time, 1,152 seconds. Holy cow, that thing went up high. Okay, because this isn't going well. Here, I need to multiply the numbers on the bottom first, then divide. That's how you're going to get the right answer. And just like we did up on number 1, find the maximum height. Uh-huh. Yes. I didn't. I did it right there. If I'd have taken my time, I probably could have done that in my head, but yeah, no, I used the calculator that time. So, once I know what my t is, to find the maximum height, h, height, plug that into my equation. So, h equals negative 16t in parentheses. When in doubt, use parentheses. Plus 144 times 4.5. What's that? What, this here? It's a good question. I don't have a good answer. So I don't have to do anything fancy. I just have to literally plug into the equations that are given to me. Nothing else. As long as I know where to find A and B, we're gonna be happy campers. So now we finally get back into the Unit 11 stuff. So now I can bust out my notes for sure and help me because I've been keeping up. So let me bump this up a bit. Try and avoid wires. Okay, factoring by the greatest common factor. Number one, the biggest number that goes into both terms. All right, where's my multiplication cheat? Uh-oh. Oh, there it is. I'm like, uh-oh. I agree with you. It's 4. If you're not sure, here's my 12 and my 16. The 4 is the biggest number that's in both of them. We do. The smallest exponent in common, which in this case would just be the 1, or just 4x even. And so once we do that, yep, to do the last part, we divide the bigs. 12 divided by 4 is 3. Subtract the exponents. 4 minus 1 is 3. 16 divided by 4 is 4. 1 minus 1 is 0. If you get 0 for an exponent, do not put a variable anymore. That's the end. You're finished. You're done. That's it. And I honestly think if you've been doing any of the practice as you go along, you're probably not even going to need the notes as you're going along. I could be wrong, but I kind of doubt it. So, okay. Factoring by grouping. Each pair that I've done there, as you can see in the examples right above it, we're going to do the exact same thing that we did in the first box. What's that? You mean like here? Well, let's see. What do they have in common? What can I pull out? 2 and the smallest exponent, x squared. Once I get that out, divide the bigs, subtract the littles. Divide the bigs, subtract the littles, and if the littles equal 0, we don't put that variable there. If you're ever not sure, okay, 10 and 5. 10 and 5, I got a 5 in each one. So we'll pull out a 5. 10 divided by 5, 2 with the x. Negative 5 divided by 5, negative 1. Remember, we're always looking to see, is this the same thing? If it is, I'm good. Because now, and if you don't want to use my little parentheses, you don't have to. So the stuff outside goes together, and your common term goes together. Done as done can be. So, I mean, really with these, and I'll admit, this is a chunkier review, and I'm kind of taking my time because I know some of you well at this point, you're going to have to pace a little bit tomorrow because you've got more going on here. Yeah. As big as the review. I'm not lying. It is. So when I get here, okay, I got my X and my X. Reminders here. Here's C. Here's B. Let's see here. If C is negative, I got one of each sign, literally telling me. So we're good there. So I'm going to go to my 32 box, or I'm going to use my brain here. It doesn't matter. Both are perfectly good tools. So find me a pair in the 32 box that are 4 apart from each other. Or an 8. You're like, okay, but which one's which? Does it matter? It does. Yeah. Well, the bigger number is going to be the sign in the middle. So 8's going to get the negative. 4 gets the positive. We're done. Again, this is going to come back to practice. Those of you that just stare at phones and chat, you're not going to get done tomorrow. I'm just telling you. I hope so. If you've practiced, you will. Hopefully. So you're like, wait a minute, though. What about... Okay, I'm giving you a hint here. All 3 of these have something in common. And if you remember back to when we were doing this initially, we said more times than not, the number in front will be the number that goes in. So I'm just going to test that theory out for a minute. Does 4 go into 32? Yes. Does 4 go into 60? Yes. So I'm going to take 4 out. So we just take that away from the x squared. 32 divided by 4 is 8. And 60 divided by 4 is 15. So my only job left now is to factor this the same way I did the first one. There's C. There's B. So again, I think back, if I need it, but if I've been practicing as much as we should be, I'm not going to need to worry about it. This is plus, which means they're both this sign. So I got plus, and I got plus. My 15 box, which pair adds up to 8, that one. And I'm set. So when I get to the last one, the only difference is now there's an equal 0. I'm going to solve it at the end. But the concept is exactly the same. So let's check this out. I notice everything is pluses again like it was in the last one. So we double plus. $27, we need to add up to 12. Well, 1 and 27 don't add up to 12. 3 and 9 does, though. Again, if you want to use my little parentheses, you can. If you're like, I'm good, Hardy, I'm just going to stay here, that's fine.
We got 3 and 5 because 5 and 3 out to 8.
The only difference is if you have the equal 0, each set of parentheses gets set equal to 0, and you solve the one-step little mini equation.
sooner ahead, like you said.
Yeah, and if you can look at that and go, it's just the opposite, that's fine. So factor it, find answers if the equals is there and it says solve. Okay. Nothing too terrible. So I go a little further. Okay, 11.5. That's why I did all this stuff, because if I need a little assistance, I can get it. Okay, there's 11.5. So let's see here. Set up two sets of parentheses. All right. Got it? Break apart your x squared, turn them into two terms that would multiply to get. Okay? One's going to be the number in front. One's just going to be x. So, like over here with 2, that's just going to be 2. Nothing different. Here we go again. So now I'm looking. Now this gets a little different. So I go and I'm like, well, 2, the only way to get 2 is 1 and 2. So this is where I'm probably going to use a pencil. Well, let's see. So if I do 1 and 2, let's do a little testing. We're doing the inside and the outside ones. Now, when I do that, does 10 plus 1 equal 7? No. That didn't work out so well, so just a minute. Let's try it this way. This is why I use the pencil. 2 times x, 2x. 5 times 1, 5x. That gets me 7x. That's the one. I'm good. You're just testing out the middle and the outside to see if they add up to that number in the middle. If they do, good to go. So like, let's play that back. 2x will be one of them. X is the other. Now, this gets a little more interesting. Because my C value is negative 10. So I know 1 is positive and I know 1 is negative. But I'm not sure where the positive and the negative goes. So if you want to just guess, we can guess. We can try it that way. And 10, I got some options this time. So let's try some options. So I got 1 and 10. Positive 1 and negative 20. I don't think that's getting a negative 1. So that wasn't cool. Let's try flipping them around. Positive 10 and negative 2. Is 10 minus 2 1? No. That didn't work. So we got to go to 2 and 5 now. Anything that's in that box pairwise, we can do. So I try this and I go, okay, so 2 and negative 10. Uh-oh. 2 and negative 10 don't work. Hardy, I'm running out of options here. My focus is not this long. Okay. Now, I look at this and I'm like, Hardy, that's really close. Like, I want negative 1 and I have positive 5 and negative 4 makes positive 1. So I got one last thing I can do. You can change the signs. You can change the numbers. We just keep rotating them until we find a way. Negative 5, positive 4, that equals negative 1. That's what I want. Like literally that time I had to do every single option open to me before I got one that worked. But that's how it works sometimes. You got to keep messing with the signs. You got to keep messing with the numbers until those middle 2 and those outside 2 get you to where you need to be. So I'm kind of glad that happened that way. That was kind of nice. Oh, and the new stuff. New stuff, here we go. Special cases. Difference of squares. What do I multiply to get each pair? Again, this should be on your notes, so I don't have to go real deep here. And so all I got to do for my answer now, x goes first, 8 goes second, 1 plus 1 minus. Doesn't matter which order. I'm done. I do the exact same idea, a little bit different of a format. When I get to my perfect square trinomial, oh my gosh, I'm all stuck in wires. Okay. I'm doing it with my first term. What do I square to get 25? 5. What do I square to get 4? 2. So the 5x goes first. The 2 goes second. Now this time though, whatever sign is in the middle on my perfect square trinomial is the sign I got to use for both of them. So if that's plus, these are both plus, like it was down here in the example. If this is minus, these are both minus, just like it is for ours. So for perfect square trinomials, this is always going to be plus. Because if it was minus, it wouldn't be. Good question. Yeah, on the trinomials, it'll always be plus, plus, or minus, minus. And so finally, these match up. Let me flip back. What do I square to get 16?
So we just don't do it.
The 20x, let me show you. The 20x is there. If I do my inner and I do my outer, the 20x is still there. We just don't see it quite as directly. Good question. And so to finish, again, I'm just using my chart. It's a difference of squares. Four x first, 3 second, plus and minus. And since it says solve, two-stepper this time. And yes, you can get fractions or decimals for answers. Do not let that throw you off. I'm happy with either. If you punch this in and you get a decimal and you say, hey, it's -3/4, I am happy with that. If you say, hey, I punched in, I got -0.75, I'm happy with that. Fractions are not bad things.
And like if it's like that, we have to like do all the rest of it. We just like the opposite of the first one.
You could. Yeah, if you notice that it's just going to be the opposite anyway, which it will be, you can absolutely just flip that over and get that set. All right, let's see what else we got here. Factor the two following trinomials. What looks different? Okay. These are all divisible by 3. So we're just going to divide that 3 out for all of these. We've already done one like this. If you were going here, divide those through. Negative 30 divided by 3. If you need the calculator, use the calculator. It's not a bad thing. That's what we've got the notes and the examples here for. So if I need to, I bust this back out and I go, okay, let's see here. I need a reminder, Hardy. I need a reminder. So I'm looking at that stuff in the middle. I'm going, okay, my C value is negative. Means there's one of each. I got this. It's under control. I look at my 10. Which one gets me to 3? 1 and 10 ain't getting me to 3. 2 and 5 will. Bigger number gets the middle sign. 5 and 2. Because that matters. Now the other one, nothing's in common. So when there's nothing in common, we go back to what we were seeing in 11.5, which is I get my 2 sets of parentheses. That's going to be my first term and my second. My C value being negative tells me it's going to be one of each sign. You remember the one where we tried every single combination before we found one that worked? Here's where we go again. So plus and minus. And we're dealing with 4, so it's got to be one of these pairs. Which pair?
Oh, it's 4 goes first, and then 1.
Okay, let's give it a shot. So let's try 4 and 1. So we give it a go. That's positive 4. Give that a go. That's negative 3. 4 plus negative 3 is positive 1. Yes, it is. And if it wouldn't have worked the first time, we'd have kept trying. So now, look how you factored each trinomial and compare. Very basic here. The first one, we had a common term. Second one, there's nothing in common. We just did guess and check. Those are the ways that we're going to have to, as we move forward, as you see this stuff again, whether it's this year or in Algebra 2 in a couple of years, is starting to learn those differences and see them, and it makes it go quicker and it makes it go easier as well. So nothing too terrible. Almost there. And I know some of you were in the panic when you asked earlier, is this how big the quiz is going to be? Close. But here's the thing. Like, we're discussing every single problem, and we're still going to be done with almost 10 minutes to spare. But again, for some of you, this may be your last kind of warning. We need to practice stuff. So, no, we got another unit still. When we get through this next unit, we're close to the end, yes. So, it's coming. So, exponent rules, reminders. We wrote this yesterday down in the help. Again, maybe something we write in the notes. I'm just saying. Multiply the bigs. Add the exponents, okay? Maybe I make myself a little note here. Again, and they have to be the same variable for you to add the exponents. So don't add all the exponents and say like it's 16. That's not right. 5 and 3 is 8. Yep. Dividing you subtract when we get there. Yep. Power to power. And again, maybe you jot down a couple of these examples on your notes. Give yourself a little help here. It would. It would. So we've got 5 to the second. 3 times 2 is 6. 6 times 2 is 12. And I can simplify the 5 squared, so I'm going to. That's kind of a thing we would do. I give myself that little hint. Even if it was just to write the original problem and write multiply exponents, that might be enough. So I get to the division. Again, the big numbers don't play by little number rules. We're not going to do a decimal, though. Math, enter. 4 over 3. Here we're going to subtract the exponents. We're always going to go bigger minus smaller. So 8 minus 7 is 1. The bigger one is up top, so that's where we're going to put it. 6 minus 4 is 2. The bigger one's on top. Because sometimes people look and they're like, well, what's up with just the x? And I'm like, well, I did 8 minus 7, and 8 minus 7 is 1. You don't have to have the 1 there. You could just have 4xy squared. That'd be fine. No. And so I do that on this last one, too. It looks a lot like the first one, so that's how I'm going to do it. Let's chat as we get here on that last one. Add my exponents. Add my exponents, but I have an issue. You can't have negative exponents in your answer. So the only thing that has to get dealt with is that right there. Well, what about that negative 15? That's not an exponent. But that is going to get flipped down to the bottom and become positive, and then we're happy. That's the only extra piece we got to deal with there. And we're going to be good. And finally,
So
yep. Radicals. We were chatting before on how, even though it's a different section, having my squares would come in handy. So we're going to wrap with this. Move up a little bit here. 48. One of your two numbers that you need to be going into 48 has to be the biggest perfect square you can find on the list. So let's see. 48 is not on my list. 24 is not on my list. Ooh, 16's on my list. So 16 and 3. See, the chart can even help me. The square root of 16 is 4. Not square root of 4, just 4. So 4, square root of 3. I'm done. Like, I used the stuff from this unit to help me with something 2 units ago. This is slick. And so, whenever I'm seeing the radical stuff, it's the same thing. I look at my 32, and I'm like, 32 is not in the list. Ooh, 16 is, though. 16 and 2. Square root of 16 is 4. Now, here's the thing. Depends on the order you're wanting to take them in. There, 4 times the square root of 2. Yeah. And since now you've got two numbers that are outside the radical, they can go ahead and be multiplied together. So we're set there. So, yes, it is. The rest of these, if the radicals are the same, you're just adding or subtracting the numbers on the outside. 2 plus 9 is 11. Sure. And to finish up, oh dear, those are not the same yet. I go looking through my 75 and I notice, ooh, 25. Okay, 25 and 3. Let's do what we can here. square root of 25 is 5. We're almost there. So 5 square root of 3, but this 3 is hanging out in front. So just like we did back here, we'll multiply those together. And then check it out. Now it works just like this one did. Now again, with me talking and talking and talking and talking and talking and talking, we still would have 5 minutes to go. You're like, that's not much time, Hardy. No, but if I've practiced and I can flow, we're not going to run into trouble. So